Good morning, students. Sorry, good afternoon. All of you,
Good
my
afternoon,
voice.
ma'am.
Good afternoon. My voice is clear.
Yes, ma'am.
Yes, ma'am.
Okay. Today, myself, Professor Smita A. Takakar, as an assistant professor in ENTC department. Today, we will learn the transistor biasing. What is meant by DC biasing of transistor? DC biasing of transistor. Depending on the application, transistor. Before starting the transistor biasing, before starting of the transistor of biasing, first recall the previous session. Uh, in a previous session, we will learn the C amplifier characteristics of C configuration characteristics, input characteristics and the output characteristics. In these characteristics, you can see the configuration. Here VBB is the supply voltage is connected to the base terminal, and the base terminal, it is a common terminal. Base is the common, is providing the input. Base is connected to the source of the base resistor, and the emitter terminal, here the emitter, it is a common terminal, and this terminal is connected to ground. That's why emitter is connected to the ground. Base terminal is connected to the power supply through the P region. Here the P region in a color of yellow, here the highlighted of P region, and it's a blue color, it indicates the N region. It is a N region. Here the formation of junctions. How it is possible in the formation of junction in a here P region of the holes. P region of the holes is moving to the right downwards of the N region, and it's created a negative charge, and some electrons here in a N region, some electrons is moving a P region, it's created a negative charge. That's why here the polarity of negative in the emitter terminal, and the negative terminal is the negative terminal of anode, and the cathode, and the positive terminal, positive is the cathode, and negative it is a supply, is passing through the base terminal. The base is connected to the P region. If the current voltage is moving through the base terminal, voltage, which voltage? Positive voltage, and current is flowing through the resistor. But the current resistance is limit the currents or control some current. That's why here the base terminal is connected to the negative terminal in the P region. That's why here the voltage IB, and here the VBE. In the voltage of in the voltage of the base terminal, here the base terminal IB is connected through the input side of the base terminal. In a base terminal, IB is connected to the P region, and the P region is a forming of negative charge. That's why the input biasing here in a input side of the emitter base terminal, it's a biasing of the base emitter voltage. It is conduct a transistor its on switch. Transistor, it is a on switch. The voltage, emitter base voltage is increase through current is also increase. The formation of junction base to emitter, this junction goes to forward bias, and transistor, it is a on switch, and the current is flowing input side. Current is flowing input side. That's why here 0 is the period origin of the 0. Diode, it's conduct the state 0, 0 0.2, 0 0.3, 0 0.4 till diode it's on in 0 0.7. Then the current is flowing input side of the forward biased. Okay, hello, you can understand forward biasing in input side. Hello.
Yes, ma'am.
Okay, then in a reverse bias, output characteristics. Here the output characteristics, transition of C amplifier. This is the C amplifier. If the input voltage, this is the biasing is forward bias, input base emitter base voltage, it's increasing through the base terminal. Then here the DC supply, which DC supply is providing the external DC power source to the VCC, and that supply voltage is connected through the collector terminal. If the collector terminal VCC and the supply is connected through the VCC and current is flowing through the collector terminal, because emitter is ground and VCE is voltage, emitter collector voltage. It is find out the output voltage. If the input voltage is increasing in forward bias, the transistor is on. Transistor is on. Then the current is flowing through the base terminal. This is input side. Then what is our output side? It's a output side current voltage. Here negative voltage, and this negative voltage is passing through the emitter terminal, and the positive voltage is flowing through the collector terminal. That's why that's why the transistor, its negative voltage is increases through the VCE in a VCE. That's why transistor goes to reversed bias, because the supply is negative through the collector terminal, and the VCE voltage is increases, the current is also increases. Which current? I max is the maximum collector current is increases through the output side in reversed bias, and transistor goes to off switch. Transistor goes to off switch. That concept, the current goes to saturation region. Currents goes to saturation region in a reversed bias. This concept is known as DC load line of the C configuration. This concept is already done in a previous session. What is C configuration? Then C configuration, you can find out the alpha DC. What is the equation of alpha DC? You can see here. Alpha DC equation. If the NPN transistor, you can see the common emitter configuration. In a common emitter configuration, alpha DC and the beta DC. We can find out the equation. This is the equation. Alpha DC is equal to IC divided by emitter. Collector current divided by emitter. And this current you can put on in beta DC value. Then alpha DC is equal to beta DC 1 plus beta DC. You can find out the beta DC. What is beta DC? Because of beta DC, collector current amplification factor in DC, collector current divided by input current, because the collector current, it is a output current, and the base current, it is a input current. That's why here the mentioning IC divided by IB. Then what is I? I is I emitter current, it is a total current. Then total current I is equal to IC plus IB, sum of the collector current and the base current. But you can find out the base current as a input, then I minus IC. And this value you can put numerator and denominator divided by I, find out the beta DC. And put a value of alpha DC. Alpha DC, it is a less than unity, means 0.9. 0.9, it is a substituting value to get the beta DC, and beta DC is in 99, higher than the alpha DC. This is the CE configuration. You can identify the equation, the rate of change of, this is the delta, rate of change of ratio in collector current divided by the base current. And still here the previous session already done. Any questions in CE configuration? And it's a comparison of configuration. Still here the previous session already done this part. Then today's session, starting of the transistor of biasing. Students, any questions? Any doubt? काही questions doubt असतील CE common emitter amplifier or configuration त्याच्या related तर विचारू शकता. हॅलो, हॅलो, समृद्धी, चेतन, अभिजित,
Yes, ma'am.
प्रसाद, any questions or any doubt in C
Excuse me, ma'am.
configuration? C configuration मध्ये काही डाऊट किंवा काही क्वेश्चन असेल तर विचारा. Then we will start the transistor as a biasing.
Ma'am, can you explain the graph again, please?
Okay. This one?
Yes, ma'am.
If हे इथे काय तुमचं बेस टर्मिनल, इफ द बेस टर्मिनल ऑफ द इनपुट VBB, the base terminal, here the base terminal, it is used as a input. Here emitter terminal, it is used as a emitter common. Then collector terminal, it is used as a output. There are three terminal in a transistor. One terminal is the input, one terminal is the common, and one terminal is the output. Then if the supply voltage, here you can use supply. Which supply? BBV. Biasing of base terminal voltage. Supply is connected through the resistor. Which resistor? Base resistor, because the terminal is connected to the base and another terminal is connected to the supply. Because here the transistor is limits the current. That's why resistor is used here, limits the current, because transistor we can avoiding or damaging for the circuitry. That's why using a resistor in input side. And it is here output side. One resistor is connected to the another terminal output side. It's a protecting of the circuitry. Which circuitry? Transistor circuitry. If here input supply voltage of the input, here the input voltage 1 2 3 4 5, supply voltage of input voltage VBE, here input characteristics. If the input voltage VBE is increased, here formation of junction, where the formation of junction in a P region, in a P region, is created a negative charge. After the formation of junction, P region is created a negative charge and the N region it is created a positive charge. That's why here the maximum voltage is increasing the voltage, then current is also increases in input side. Here the input side, input IB if, and here you can see the output side VCE. If the collector emitter voltage is connected, collector emitter voltage is connected through the output side. This is the output VCE. You can see the VCE is a resistor of the RC, collector resistor. VCE, output voltage. If the output voltage is increases, according to the collector current is also increases. Here IB, it is a input current, and VBE, it is a input voltage. If the voltage is increased in input side, then current is also increased. And if the input and voltage is increases, then the transistor goes to forward bias. Yes, na? And that's why the transistor, it is a on switch. Then reverse biasing here in an output side. VCE, if the collector emitter voltage is increased through the collector terminal, where here the negative point is connected to emitter and emitter is common. That's why here not flowing through the current. The current direction is upper side of the collector resistor. Through the collector current is downwards and the some emitter current is also downwards. That's why the transistor goes to VC, emitter collector voltage is increased, then the collector current is also increases and the transistor goes to reversed bias, because here junction with junction, negative junction. Here you can see negative junction. N is connected to the collector terminal. N is connected to collector terminal. If the junction, collector junction is formation in a P region, it is created a negative charge. Some electrons is moving to holes and combine. Some electrons is moving to P region and combine with holes, and that is created a negative charge in P region and it is created a positive charge in N region. That's why this supply is positive and some supply is going to here. DC power supply. It's a DC power supply is also positive. This positive terminal and electrons is also positive. That's why transistor goes to reverse the bias. Okay, got it? Samruddhi?
Yes, ma'am.
Okay. And that's why transistor goes to reverse bias and it is a off switch. And some current is flowing, voltage is flowing. This is the characteristics. If the voltage is increases, then current is also increases. If required the input voltage is 0.7 volt, then the transistor it is activate. It's 0.7 volt. After the output side 1, 2, 3, 4, according to the input voltage is increases, the output current is also increases. It is a milliamplifier into 10 raised to minus 3. And voltage, it is a 1 volt, 2 volt, likewise. And here the current, which current? Input current. This is the active region. If the transistor is on, it's a forward bias in input side. If the transistor is on, in reverse bias, the junction of collector emitter junction is reverse bias, transistor goes to close switch, open switch, and it is a reverse biasing. This region is known as active region. Then third point you can see common collector is not biasing. Here today's we will starting the concept of biasing. If the transistor cut off, if the You can see the right side of the table, table number 3.101, region of the operation. If the cutoff region, which cutoff region? The transistor goes to 0.7 volt. Transistor goes to voltage is 0.7 volt. This is known as the transistor is a cutoff region, the junction of base to emitter. Base to emitter, it's the junction of reversed bias, and base to collector. Here the collector output side, it is a constant. That's why output it is also reverse bias. This region is known as cutoff region. Then next region, active region. Where is the active region? If the transistor, if the input forward biasing VBE, it is forward bias. The transistor is a active region in emitter base junction, and collector emitter junction, second junction, it goes to reverse bias, and that's why transistor goes to off switch. This is the concept of active region. And third one, saturation region. If the current voltage is stop, means after 5 volt the stop voltage is stop, but the some current is flowing through the reverse biasing, because this concept is known as transistor goes to reversed bias. Diode in a reversed bias, it is a closed switch, no current is flowing. Same one, there are a transistor two diodes implementation in a single ट्रान्झिस्टर, दोन डायोड पासन काय होतोय माझा, एक ट्रान्झिस्टर डिझाइन होतोय. that is meaning of the single transistor in a reverse bias, the current is flowing through the whole circuitry. This concept is known as both the junction. Emitter based junction is a reverse bias, and emitter collector junction, it is also reverse bias. That's why transistor goes to saturation. And here the slope for the beta DC and alpha DC according to the current. It is a transistor, bipolar junction transistor. It is used as a switch because it's a current control device. Because it's a current control device. And here the comparison of configuration, CB configuration, CC configuration, and the CE configuration. In this all three configuration, the C amplifier or the CE configuration is the better configuration to amplify the signal. Why? The input voltage, it goes to forward bias, it is an active region, transistor is on, and it's a output voltage, it's a transistor works in reverse bias, then it is also active region. That's why it's a low input resistance and output is very high. That's why it's use a C amplifier. Then transistor, it's a biasing. With this today's topic, depending on the application. Transistor operated, there are three regions. Which three regions? It is a cutoff region, active region, and the saturation region. These three regions is the main part, it is operated in biasing. Then two junctions, which one? One is the emitter base and collector, and another is the emitter base is the one junction and collector base is another junction. It works in forward or the reversed bias. You can see here DC load line. Then in a DC load line, you can see is the red marks in the characteristics. This characteristics is already done in C amplifier or the C configuration. But how to draw this line? This is the draw under a straight line equation in a mathematically. What is the equation of straight line? Straight line is equal to y mx plus c. mx plus c. You can see the configuration. DC load line. Here DC load line or the quiescent point. Then equation. Common emitter configuration in a circuitry. common emitter configuration. You can to understand the concept of DC load line, then consider C, common emitter configuration. If the common emitter configuration VBB is the input through the base terminal, current is flowing through the circuitry. Which circuitry? Emitter terminal is common. Any ground, base terminal is input, and this is the output VCE. VCE is the output voltage, and the IC, it is a output current. And here VCC is additional supply. You can connect here the supply. Maximum amplified the signal amplified करण्यासाठी here connected to the VCC. ज्याने काय होईल माझा amplification is possible in C amplifier, maximum amplification. Then here emitter input biasing, I will remove here. Only collector circuits in the diagram number B. See on only collector circuits. Which collector circuit? Base is open. Emitter terminal is ground. And here the RC. RC is the collector resistor. And the current is flowing positive supply positive to N region. Here the collector terminal is connected to N region. Emitter terminal is connected also N region. That's why maximum electrons is flowing in output side. That's why you can apply here C configuration in reversed bias. Why? Because VCE, it is part of the transistor is off in reversed bias. ट्रान्झिस्टर हा माझा ऑफ होतोय ना रिव्हर्स बायस मध्ये. हॅलो स्टुडंट्स, यू कॅन अंडरस्टँड. तुम्हाला समजतंय का सी एम्प्लिफायर? Okay. Then here we can apply the KVL law. What is mean by KVL? Kirchhoff's voltage law. Here you can find out only voltage. VCE is voltage. VCC also voltage. Then here the negative VCC minus of the VCE. Emitter to collector. VCC minus of VCC minus of IC and RC. Because it's a multiplication, voltage is directly proportional to the resistance and the current. It is known as Ohm's law. Then apply here KVL to circuit. VCC minus, here polarities of minus flowing to the reversed bias of VCE minus of IC into RC is equal to 0. This equation number 1, 3.10.1. It is the one equation. Then second equation you can rearranging, then find out the collector current. What is the collector current? This is the maximum current is flowing in a reversed bias of the output side. That's why IC is equal to minus IC divided by RC into VCE plus VCC divided by RC. And these equations you can arrange straight line equation. IC is equal to Y, M is equal to minus 1 divided by RC, and VCE, it is the X. You can see here the equation 3.10.3. X is VCE and plus and a C of the VCC divided by RC. If the straight line in the DC, if the straight line is a DC load line, if the straight line of the DC of a DC load line, the equation I is equal to mx plus c. According to the equation of this straight line, we can find out output current is equal to input current. If the output current is maximum, then the current is also maximum. If the output voltage is maximum, then the current is maximum. But here output voltage we can consider here directly 0. Now substitute Vc is equal to 0. जर मी VCE 0 केलं, हे VCE जर 0 केलं, output emitter collector voltage is 0, then M is also 0 because it's a multiplication factor mx. M is 0, then x is also 0. X is 0, then M is also 0 because I am substituting 0 for VCE. That's why IC is equal to VCC divided by RC. IC divided. IC is equal to minus RC VCE and VCC. If the substituting the current equation 0, then the output voltage is 0, IC is equal to IC max, and that point you can increase substituting IC 0. जर व्होल्टेज 0 असेल तर माझा करंट मॅक्झिमम असेल, आणि जर करंट 0 असेल तर माझं व्होल्टेज मॅक्झिमम असेल. These 2 points we can identify the DC load line. If the voltage is 0, that point current is increased, and that point is naming of point A. And if the current is equal to 0, then voltage is increased, and that points you can here mentioning B. A is 0, voltage is 0, then current is maximum. You noted a point A. Point A. If voltage 0, then current is maximum. And if the B, current is 0, output voltage is maximum. That's why here in a DC load line, if the IC current goes to saturation, already told in a common emitter configuration. इथे मी ऑलरेडी तुम्हाला सांगितलंय, in a reversed bias voltage is minimized, then current directly goes to in a saturation, collector current. That's why the collector current is goes to saturation. The transistor base to emitter junction is a forward bias, and emitter collector voltage means emitter collector based junction, these also forward bias. Then transistor goes to saturation. Both the junctions are using forward bias. Then current goes to saturation, and that point is a center point, is known as quotient point or the Q point to identify. Find out here the flow. Slope IC max, and here VCE. Collector current is maximum. That equation is equal to VCC divided by RC. And if the collector voltage is maximum, that is directly equal to VCC. And DC load line, you can find out the center. That point is known as Q point. Then Q point is a point or the still quiet inactive. That point is known as biasing point. Where biasing point? If input voltage is increased, then current is 0. And if the current is increased, then voltage is 0. That's why BJT, bipolar junction transistor, we can use a current control device. You can controlling to whole circuit only current. Okay, and it's a biasing circuits, like a biasing circuit you can see here. Open circuits means open base, and here supply voltage. This circuit of the input side, it is a open, and output side we can see the output voltage VCE and output current, and the center of the Q point, this meaning of the DC load line. What is DC? Direct current load line. Draw. This is the draw under DC load line operating point. Here operating point. Where is the operating point? A is the if the current is equal to VCC divided by RC, then the voltage is constant. And if VC is equal to VCC, then here current is constant. That's why center point of the Q, you can amplify the signal. It is a positive half cycle, is the positive sine wave, and negative half cycle, negative sine wave. This is all 360-degree sinusoidal wave. If the input is passing sinusoidal wave 360-degree, the output will be get 360-degree. Here input is minimum 10, 20, 30 milliampere, but each some milliampere will convert directly 100, 200, 300, 400 microampere. It's amplified the signal to the input side and here the output side. Here collector current and here base current. Input is increases according to the output is also increases, and this concept is known as common emitter configuration DC load line. Okay. Typical junction voltage. If the cutoff is 0, silicon transistor, and here germanium transistor. But in electronic circuitry, this is the electronics PCB design, printed circuit board, and this board is the Xilinx board for the latest application like LED screen, TVs, monitor screen, smartphones. We can use this implementation. And the internal base, this is the base, emitter, and here the collector. If the transistor cut off, that is the 0. Cut off and 0 means the starting of the origin. If the cut in, exactly cut in 0.5, it's a cutting of the transistor. VBE, it is active, means diode transistor, it's active in forward bias 0.7 volt. The VB is saturation, current goes to, voltage goes to saturation 0.8 volt. And the point number 1, 2, 3, 4 related to the base emitter voltage. It is a forward biasing. It's a active region 0.7 volt. Saturation, then the current, input current goes to IB, saturation 0.8 volt. And here saturation of output side, VCE, collector, emitter collector voltage 0.2 volt. This is the initialized 0 point required in a silicon transistor. That's why common emitter configuration, we can use transistor as a switch in current control device. And here some biasing types like fixed bias, collector bias, self bias, emitter resistor, biasing resistor. This is only types in your syllabus, not detail in this. Then if the this one you can explain in next lecture. Single stage RC coupled. Single stage RC couple. We will continue to next lecture. Then any doubt in biasing of circuit in C amplifier? Hello, student, any doubt in biasing of the circuit?
No, ma'am.
Then all of you understood for C common emitter configuration why using BJT or the transistor as a switch. Yes, it is a amplified circuits. Okay. Thank you all for replying. जर काही डाऊट असेल तर रेज युअर हँड करा. Then I will note down for some questions. Okay. Then shall I conclude here meeting? No doubt or no questions? क्वेश्चन्स असेल तर विचारा. समजलं का? ट्रान्झिस्टर कॉमन इमिटर का यूज करतोय आपण? कॉमन इमिटर, कॉमन याने ग्राउंड आणि निगेटिव्ह पोलॅरिटीज ज्या माझ्या आहेत ते मी काय करते, कॉमन करते. इज कनेक्टेड टू द अर्थिंग and the supply voltage will provide for the junctions. Which junction? PN junction. जर माझं पीएन जंक्शन हे डायोड असेल तर ते फक्त नॉर्मल पीएन जंक्शन डायोड वर्क करतं. बट ते ट्रान्झिस्टर असेल तर टू वेजने फॉर्म करतं. वन बेस टू इमिटर जंक्शन हे माझं इनपुट साईडला असणार आहे आणि बेस टू कलेक्टर जे आहे ते माझं आउटपुट साईडला असणार आहे. इफ मी इनपुट साईडचं जे माझं कॉमन इमिटर आणि कॉमन बेसचं जे सर्किटरी आहे ते जर फॉरवर्ड बायसिंग नी वर्किंग होईल तर माझा ट्रान्झिस्टर काय होईल, ऑन होईल. आणि इफ द ट्रान्झिस्टर गोज टू रिव्हर्स्ड बायस in a output side like a emitter and collector terminal, that's why it is operated in reversed bias. And the transistor goes to active region if the junction of base to emitter is forward bias, and if the collector base junction it is a reversed bias, then transistor goes to active region. and the transistor हा forward bias असेल तर जो ऑन स्विच असेल आणि ट्रान्झिस्टर हा रिव्हर्स्ड बायस असेल तर तो ऑफ स्विच असेल. कधी ऑफ स्विच होईल? इफ द आउटपुट साइड कलेक्टर करंट इज मूव्हिंग थ्रू द ट्रान्झिस्टर, द transistor goes to reversed bias and this point is known as transistor is a off switch. And the point, if the input passing through the input side the transistor goes to on switch, it is a forward bias. And how to draw the DC load line? If the input voltage through the collector current, हे collector current IC is equal to VCC divided by RC. VCC and a power supply voltage divided by the collector resistor, then is known as voltage is equal to constant. म्हणजे voltage it's a zero, then you can draw the maximum current A point. And if the current is equal to zero, then you can write down VC is equal to VCC. Output voltage is equal to emitter collector voltage. And draw this line, drawn under the line. Which line? Under the line of here. DC word indicates the line. Which line? The straight line. Here you can find out the equation y is equal to mxc plus c. And these equations is the DC drawn under DC operating condition. Current, direct current operating condition is the DC, and load line you can find out the slope. But the slope is minus because of its biasing in negative side or the negative supply. That's why here minus RC. And draw the DC load line and center point is the Q point. You can draw here slope. The current goes to saturation. This concept is known as quiescent point or the Q point, and it is correlated to the input output current IC and the output voltage VCE. Okay. Okay. Okay, students. Thank you all. Here I am stop the recording. Recording is stopped.